Okay, phone. This is gonna be tricky because I'm using my phone for the Hangouts. I can't use my other hand, so I've got to. So hope flying all over the place.
It's okay because I don't see you the whole time because I have it on the meeting thing, or on the quiz.
I know. I just don't want the phone to fall on the floor because then you can't hear me.
Oh, true.
Okay. Following data file.
Everybody got the first two answered?
Yep.
Okay.
Yeah.
I'll read the first question then. Suppose we have a set of paired data and let the difference be x after minus x before. The null hypothesis is the different, whatever, mean of the difference is 0 equals 0.
The difference,
yeah, the alternative hypothesis is that the mean of the differences is not equal to 0 and the population standard deviation is not known. Jordan collects a sample of size n equals 9 and computes the, whatever that is, to be 2.2 and the standard deviation to be, or the sample, whatever that is, to be 3.3. So we need to find the value of the test statistic.
Okay, so somebody remind me how to do that?
That will be...
We're going into the quantitative procedures, right? Or are we doing that freehand?
The inference, quantitative inference procedures. Yes.
Procedures. Yeah. Mm-hmm. That's the one.
And go to the paired sample t-test. And then if you don't have the data, then you can just enter in the summary statistics, which is what they just gave us.
Okay.
So in that top little blue section where it says mean, we would just put the 2.2.
Okay, so the mean.
And the standard deviation is 3.2.
2. And standard deviation is 3.3. And n equals 9. And does it say confidence level or no?
No, but I think we always just assume 95. Unless it's,
yeah, because that's kind of what it comes up to automatically.
Different, yeah. The 0.95 would not affect the t value anyway. It would only affect the probability. So the null then is 0, and the type of test is not equal to.
Right, but mine is giving me like crazies.
So it should under the t. Does yours say 2.000?
Yes.
Does yours say that?
Yeah.
Caitlin? Okay.
It says 2. It's 2. The answer is 2.
Yeah.
Yeah. Are you guys going to put 2.000 or just 2?
I will put all the zeros in because it says round to, well, it doesn't say on here to round to 3, but why not?
It does right before the information part of it. It says, please remember to round to 3 decimal places.
Yeah. Okay. Okay. So I'll read question 4. The probability of obtaining a test statistic greater than Jordan's test statistic 0.0403. Use this probability to determine the p-value for Jordan's hypothesis.
I have no idea how to do that.
I
Was
don't
that even
either.
on the homework?
Let's find out. P-value and...
I don't recall that being on the homework at all. So I don't know. I'm going to defer to you guys on this one.
Um, well, it's something to do with p-values. And we have, ow, ow, ow. We have, we already have his p-value, the p-value for his test, right?
Yeah.
So wait.
But what does that have to do with that p-value? I don't understand.
I think I'm pretty we enter into the T whatever T distribution that the app, the T distribution applet, and find out the T value, because the probability of obtaining a test statistic greater than his count, so then we should be able to determine the p-value for his, right? Because that's what the top of it does, is determines the p-value, giving us the number that goes on the bottom of the thing, right? And then,
okay, I see your logic.
like, does that make sense? Am I making sense?
So you're saying if you type in 0.0403 into the T applet,
and then, but we need to know what's greater.
that will give us a different T score?
I don't think no, it won't give us a different T-score. It'll give us the p-value.
P-value. So, because it says Jordan's T-score is 0.0403, right? So wouldn't that be what we put in T?
No, that's the probability of obtaining the test statistic greater than. So I'm assuming that means only the right tail should be shaded. Then we type in 0.0403.
And 8 degrees of variation?
With 8 degrees of variation, yep.
Wow.
And then, so
that gives a T-score of 2.444. No, I lied. Well, it's basically 2. It's exactly the same. The probability is exactly the same. Are you guys seeing that too?
Well,
if you shade just the green on the right hand side,
right,
with 8 degrees of freedom and an area of 0.0403, the T-score is 1.999. And his T-score is 2, which basically means to me the same thing. So I think we should enter the probability off of the spreadsheet.
Let's just do the p-value from the spreadsheet, because that's the one that seems like it.
Yeah. So 0.081. Does everybody agree on that?
Yeah.
Yeah.
If we get that wrong, we got to come back and figure that one out.
Yeah.
I didn't see anything like that on the.
Yeah, I don't know.
On the
Okay. Okay, I'm gonna try and get this to work, but I do not know if it will. Because the next one we have to use the thingy. Okay.
Okay.
Okay. So use the data file, chapter 12, data A1, to answer the next 6 questions. Perform a paired samples t-test in SPSS. Be sure that the test does group 1 minus group 2. Use the null hypothesis of HO equals the mean difference equals 0. And the alternative hypothesis is mean difference does not equal, or is not equal to 0, and a significance level of 0.10. What is the T?
The test is okay. Okay, so chapter 12, so group.
Okay, so calculate your differences.
Equals. It's group 2 minus group 1 or group 1 minus group 2? I missed that.
Group 1 minus group 2, right?
Group 1 minus group 2. Okay.
Okay.
Group 1 minus group 2. No.
Null hypothesis is 0. Okay.
Okay, I'm having issues in that, and I had the same problem before. I can't get, like, I can do the first one, but I can't get it to go on the rest of the columns. What am I doing wrong?
Formula down? You can't copy the formula down? Is that what you mean?
Well, the formula is there, and that's fine, but once the formula is there and I've got the answer, like, I can't make the rest of the columns come up with the same answer.
So click on the top column.
Okay.
And then there's that little tiny square in the bottom right-hand corner where it kind of gives you a crosshair when you click on it, or when you hover over it. You click on it and just drag it straight down.
No, 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 don't do that. Sorry, it just did something bad.
Did that make sense?
It does make sense. I just did something wrong. Okay, there we go. I think I got it. Yep. Okay. I have that information, and now we're entering that column into the data whatever thingy. Yep.
You're putting, just copy all 3 columns into the, copy all 3 of them into the paired sample.
Wait, how? Okay. It's not going to cause a problem if I don't get rid of the formula, right?
No, because when you do
how to do that.
You paste, so just copy all 3 columns.
Okay.
And then select the first cell in the inference procedures, like in there, under variable 1, so it's like A5. And then just right-click it and do a paste special and just paste the values.
Paste special and paste values. Okay, cool beans.
And then it should just give you the numbers.
Copy the 2 columns over, the 2 variable columns. And then the difference is when I just put that formula that equals A5 minus B5. And then I was able to get it to pull all the way up with all of them.
Oh.
Without having to go to another sheet or anything.
Well, no, I think I got it. Okay, so wait. We're testing 90%, right? 90% confidence level?
Right.
Because it's
so
10.
Confidence 0.9, null hypothesis 0, Type of test not equal to.
And that's it, right? Okay. So.
Did you guys get a t value of 0.407?
Yes.
Yes.
Okay.
Okay, so test statistics. Test statistic is 0.407. And the p-value is the next one.
0.689.
Which is,
yeah.
Yep.
0.689.
Okay, are we rejecting or failing to reject? What is?
So 0.689 is less than 0.10, so we reject the null.
No, it's not. It's greater than.
Oh, it's greater than. Sorry.
It's greater than, so we reject it.
So we fail to reject.
Oh. I always get that backwards, like every time.
I do too.
I
I always have to reread it like
in my notes.
No, there was a little thing, and I need to go in and write it down. There was a little thing in her announcements this week that was like, I should write that down because it's about failing to reject it or rejecting it, whatever. So we failed to reject it, yeah?
Yeah.
Yeah.
Okay.
Here's what I have in my notes. If the p-value is less than the alpha, we reject. If the p-value is more than alpha, we fail to reject. Fail to reject means there's insufficient evidence, and reject is that there is sufficient evidence for the alternative hypothesis.
So p-value is less than the null.
No,
reject.
if p-value is less than the alpha, which is the level of...
Oh, then alpha, right, sorry.
Yeah.
Less than alpha.
P-value is less than reject. If the p-value is more, then we fail to reject. And then it keeps asking...
Because wasn't our level of significance 0.10 this time?
Yeah.
Right. So 0.689 is greater than 0.10.
Oh, it is, right. Never mind. I'm reading it. 6 is less than 10 in my mind. So.
That's exactly what I said in my...
Yeah, but if you think about it, though, I always, and I need to stop doing it, but I always convert decimals into percentages. Mm-hmm. And so I look at it as 68% versus 10%. 68% is bigger.
Right.
Yeah.
It at least helps me in this, although I probably need to stop doing it before I mess up other things. Okay.
All right. So 6 is saved. So 7 is fail to reject.
Mm-hmm.
Uh-huh.
And 8.
Who's reading?
I will.
Okay.
Suppose your alternative hypothesis is instead that the mean of the differences is greater than 0.
Okay, so then we go in and change it.
Now we have to go back and we change it.
Change it to greater than, right?
Greater than.
Yes.
And that changes the p-value, but it does not change the result.
Right.
Yes.
So
we have
still greater, so there's insufficient evidence.
So we have insufficient evidence that the mean of the differences is greater than 0. The second one, right?
Yeah.
Okay. Okay. So
So now we have a new set of data.
Okay, so use the data from Chapter 12, data B1, to answer the next 8 questions. Perform a paired samples t-test in SPSS. Be sure that the test does group 1 minus group 2. This data comes from, I'm not reading that. The null hypothesis is that the mean is equal to 0. The alternative hypothesis is that it is not equal to 0. The level of significance is 0.1. All right, so let's go in. I am going to I'm going to try and get this done. We'll see if it works. I don't know if it will. Okay, so it equals 1.
So we're changing the thing to 0.99, right? The confidence level.
Yes.
And 0 for the null and not equal to for the type of test. But we have to change the data here.
Okay, come on. Here we go. Sorry, I'm having issues, guys. I'm having issues. It's true. This is very difficult to do one-handed. Ah, come on. They did not design copy and paste for a one-handed person. This is lame. Okay, no, not that. Not that. Wrong page. Here we go. All right. Go up. No, go away. Okay. Confidence level. I'm sorry, guys. I'm taking so forever.
Okay.
No, you're fine.
It's not equal to. Okay, so just to make sure I'm on the same page, the number is 22, and the t-score is 3.737.
Yep.
Yep. Okay, cool. I'm on the same page. Hallelujah. Okay, which is greater, N or DF? Always N. Come on, always N. DF is N minus 1. That's just silly.
What is
okay.
P-value? 0.001?
Yep.
Yeah. One. I once put O's instead of zeros on here and failed that answer.
Uh-oh.
Because I'm brilliant. All right. What decision do you make? Reject.
Yep.
Right?
Yeah.
All right. Yay, I got it right.
Let's see. So you decide to try another alternative hypothesis. This time you use the mean of the difference is greater than 0, and you keep the same level of significance. Did the p-value increase or decrease?
Okay, not equal. Changes to greater than.
And
decrease.
Decreased a lot.
Decreased dramatically. What decision did you make? Reject.
Okay, based on your response from the previous question, what conclusion do you make? So if we reject, then that means there's sufficient evidence
that there is a mean difference between the two groups, right?
Yes.
Or is there no mean? Because there either is a mean difference or there's no mean difference. But
well, we were testing to see if the mean was greater than 0, so that would mean that it.
Well, it's not just that the mean is greater than 0, it's that there's a difference between the means in the two groups.
And the difference is 11.955 is what the Excel thing says.
Yeah, so there is one.
Yeah, so there is sufficient evidence that there is a mean difference between the two groups.
Sweet.
This is a lot different than the homework quiz.
This is breaking my brain. All right. As we have seen, the p-value depends on the alternative hypothesis, obviously. In general, which alternative hypothesis will give you the smallest p-value? I think it depends on the problem.
That's what I feel like. Because wouldn't the data make a difference?
Might not. Hold on. Let me try something real quick. No. That has to depend on the problem because we don't know, because it depends on which tail it is.
Well, this is telling you which tail it is. It's saying that the less than, that the mean of the differences is less than 0. So if you just go over and just change it, so less than gives you a probability of 0.999.
No. What I'm saying is, like, is that going to be true of every problem that we have? Or are some of them going to be left-tailed problems as opposed to right-tailed problems like this one? Because like this one, we were figuring out the right tail and the right tail was smaller. But what if the next one we have to figure out the left tail and the left tail smaller?
But it's not asking for it's only asking for the left tail.
Is this one like a general question or is it according to this problem?
This is a general question.
Well, that's what I'm saying.
So I think the smallest probability is when the mean of the differences is less than 0 or less than the null.
What do you mean? It's less than? No. We want the smallest.
Would it be greater than?
So the smallest p-value is when is when 0 is right. Wait, hold on.
So
when the mean is greater than 0.
The one tail, it's asking if the less than is a higher probability or lower probability than the not equal to, and I think the not equal to is always the one that has the lowest probability. So I think it's the first one.
Well, it doesn't though. Because like if you look just at our problem, if you look at it, like the problem that we just did, the not equal to was significantly bigger than the mean is greater than 0.
No, because if all you're doing is switching the type of test, if you do not equal to, which is the first option, then the p-value is 0.001. If you change it to less than,
to greater than.
But that's not the question. The question is whether it's less than.
No, it's woo. Hello, my computer just did something strange. No, it's not though. It's asking if
you look at it, look at the second option is that the mean of the distributions is less than 0.
Right, but it says, as we have seen, the p-value depends on the alternative hypothesis in general, which alternative hypothesis will give you the smallest p-value. But then it gives you the 4 options.
There are only 2 options.
There's 4.
Oh, isn't there? Oh.
See?
I didn't scroll down.
See? There's 4 options. And I don't know if it's not enough information or if it's greater than. If we're going off the problem, wait, hold on. La-di-da-di-da-di-da. Okay. The next 8 questions, which is 1, 2, 3, 4, 5, 6. This one counts. So mean is greater than 0. And we're using the same information and we're changing it. Sorry, moving on to question 16. Using the same information, we're moving it from 99% confidence to 95% confidence.
So for number 15, did you do mean is greater than 0?
Yes. Because for that problem, that's true. And it's supposed to be based on that problem. Okay. My brain has gone to sleep. What is the point estimate? How does that work?
Point estimate for this 95%
yeah, what's the point estimate? I forget.
The point estimate, that's the middle, isn't it? The middle of the confidence interval. So you would do this.
1 plus 1 divided by 2?
Margin of error.
Is that a crying child or a squeaky door?
It's a mean, isn't it?
No.
Is that right? I don't know. I feel like not enough of this stuff was covered in the chapter.
Okay, we're still using the same data from the B, right? From the
right.
I think so.
Right, yes. This is the last one, but I just counted them all up. So it was the next 8 questions, and this is the last one.
So we need to change. We just need to change the confidence to 0.95.
Right. And then the point estimate.
So that would be, I think it's the upper bound minus the lower bound.
Divided by 2?
Divided by 2, and then you would just do a little bit of math right there. I think that's. Wait, isn't the one divided by 2 your margin of error?
Yeah, but the margin of error is the point estimate plus or minus.
Right. Okay. We'll do it that way, and if it's wrong, then we'll redo it. Because I think, I'm not 100% positive, but I think that's right, because I just went and looked it up. Okay, so it's the upper, which is 18.605, minus the lower, which is 5.303, divided by 2. 6.652. Yes?
Yes.
So the point estimate would be 11.955.
What? The point estimate would be 11?
11.955, because it would be the upper bound minus the the upper bound would be the point estimate plus 6.652, and the lower bound would be the point estimate minus 6.652. So the middle ground is 11.955.
Oh, so the point estimate. Gotcha. Okay,
That makes
so
That's my guess. If I'm wrong, I'm sorry.
You lost me on that.
That's the mean of the differences.
Yeah.
Okay. Yeah, that makes sense. I don't think did it ever say that that's what it is?
I don't know.
Like in the chapter, did it actually define it? Like, oh, the point estimate is the mean of the differences. I don't know that it ever said that.
No, I never said that.
Okay, well, there's two ways of figuring it out then. So we should be able to figure that out.
I'm guessing
so the margin
that
of error then is the 6.652, right?
the margin of error is
As we just did that calculation to get the
right. 6.652. Yep.
yeah.
It should be.
Now we're doing the 11.995.
Yes.
For a 16, yeah. So 6.652 is my guess. It's an educated guess, but it's a guess. Okay. And put the lower bound as 5.303. And the upper bound is 18.607. Save. All right. We ready?
Mm-hmm. I'm curious, what number did we have a hard time with? Did we get it wrong?
We missed
Oh, we
2.
did get one wrong.
Which 2 did we miss?
The point estimate.
Oh.
And the p-value one right above it.
Yep. Wait, I only missed 1. I just missed the p-value one.
I missed 15. Yeah, 15 is the only one that I got wrong.
What did you put for yours? The point
Point
Bree,
estimate?
What'd you put?
11.995?
No, 11.955.
9. Oh well.
That was a lovely typo. Okay. So the p-value is wrong. It depends on the alternative hypothesis. Smallest p-value.
Then in that case, I would say it's not enough information.
Yeah.
Yeah.
And and it depends on the problem, because this problem, that's true, but other problems it might not be.
Right.
Okay. I don't know
I'm
if
not
I'm
going
gonna
to go back and change mine.
I don't know if I'm gonna go back and redo it or not. I'm a big fan of
the answers
getting 100%
just
on all of these, so I might go back and redo it.
I think I'm going to call it good and go to bed. I'm tired. And lazy tonight. Okay. Well, we did better than I thought we would, girls. I mean, honestly. That was a little bit harder. I'm going to have to go back and look at the lesson again, because half of the stuff that was on here, I don't remember actually being in the lesson. Like, I think we just were using our...
Yeah, I think there's something, like, because she has, like, the helps and stuff, you know, like the additions to those chapters. And I think that's where all the information is, because, like, half of this stuff I'm sitting there going, this was not included in this chapter. This was not in the textbook.
Mm-mm.
Yeah. I don't remember reading.
I agree. Yeah.
Well, I mean, some of it is just, like, really understanding the Excel page. Like, because I think that's a lot of it, is just really making sure that you understand it. But the rest of it is like, but we never learned how to get that. So yeah. Okay.
No. Okay. All right. So let's come back with ideas on Wednesday for our project, maybe.
Okay. And make sure that you review and look at the project, like look at what the project parameters and everything are.
Okay.
Okay.
So that way we know if we need to get 2 sets of data.
Okay.
Okay.
Very good.
Sounds good.
See you guys on Wednesday.
All right.
All right.
See ya.